everything you ever dreamed. Wanna be who?
The switch hub is facing the two computers at an 80 degrees angle. PC1 is connected to the switch hub using a 52-meter cable and is facing at an angle of 45.5 degrees. The distance between PC1 and PC2 is 44.5 meters. How long should be the cable be in order for PC2 to be connected to the switch hub?
This is our problem number 1. The switch hub is facing the two computers at an angle of 80 degrees. PC1 is connected to the switch hub using a 52-meter cable and is facing at an angle of 45.5 degrees. The distance between PC1 and PC2 is 45.5 meters. How long should the cable be in order for PC2 to be connected to the switch hub?
This is how to solve it.
So this is the orientation for our problem. The switch hub, which is 80 degrees, PC1, which is 45.5 degrees, and PC2. The distance between the switch hub and PC1 is 52 meters, and the distance between the two computers is 45.5 degrees. Side A, which is the distance of the switch hub and PC2, is missing.
So for law of sines, this will be our formula. A is over sine angle A equals to B over sine angle B equals to C over sine angle C. So for this case, we have to use what is given. So side B and angle B is given as well as angle A. So in this case, this will be our formula. It will then be derived into side A is equals to B sine angle A over sine angle B.
We then substitute the values.
But first, don't forget your cycle. Now we will start to solve the problem.
The value of side B is 45.5 meters, multiplied by sine A, which is 45.5 degrees, over sine B, which is 80 degrees. Yes. In order to solve, we must first find sine 45.5 degrees and sine 80 degrees. So first, we write 45.5 meters.
And using our cycle, sine 45.5 is equals to 0.713. So we have to stop in 3 decimal places. And on the other hand, sine 80 degrees is equals to 0.985.
Now we can solve the problem.
We now then multiply, then divide. So 45.5 meters times 0.713 is equals to 32.4415. Since, like we said, we're going to stop in 3 decimal places, we will be rounding it off. So it will be 32.442 over 0.985. We now then divide 32.442 divided by 0.985. So side A is equals to 32.94 meters.
So this is the final answer.
So this will be the distance of the switch hub and the PC2.
In a badminton drill, a shuttlecock is placed at the left side of the court, 270 meters away from the middle of the court where Basco is. He runs toward the shuttle and picks it up, then goes back to the middle. At what angle does Basco turn to run to the other side when the distance between the two sides is 350 meters?
This is our problem in law of cosine. In a badminton drill, a shuttlecock is placed at the left side of the court, 270 meters away from the middle of the court, where Basco is. He runs towards the shuttle and picks it up, then goes back to the middle. At what angle does Basco turn to run to the other side when the distance between the two sides is 350 meters?
So the given in our solution is where A and C have both the same values, which is 270 meters and B is 350 meters. And the missing angle is B. So the formula in our solution is cosine angle B equals B squared minus A squared minus C squared over negative 2 times A times C. So, where B is 350 squared minus 270 squared minus 270 squared over negative 2 times 270 times 270. So, 350 squared equals 122,500 minus 270 squared equals 72,900 minus 72,900 over negative 2 times 270 times 270 equals negative 145,800. So 122,500 minus 72,900 minus 72,900 over negative 145,800 equals 0.16. So, cosine angle B equals 0.16. Angle B equals shift cosine 0.16 angle B is equals to 80.79 degrees.
This is the final answer.
As part of the dance, Joshua is asked to hold a 141 long-inch ribbon attached to a pole. The height of the pole is 68.4 inches. So what is the distance of the pole from Joshua?
This is our problem for right triangle. As part of the dance, Joshua is asked to hold a 141-inch long ribbon attached to a pole. The height of the pole is 68.4 inches. What is the distance of the pole from Joshua? Let's get our calculators and let's solve. This is the solution on how to solve our right triangle. The given are the opposite, which is the pole, is 68.4 inches, and the hypotenuse, which is the ribbon, is 141 inches. The distance that we're trying to find is the adjacent. This is the given formula. A equals the square root of h squared minus o squared. Now we're going to substitute the values. Equals square root of the h, which is the ribbon, is 141 squared minus the opposite, which is the pole, is 68.4 squared. The first thing we're going to do is solve the inside, which is the square. The square of 141 is 19,881 minus the square of this is 4,678.56. The next thing we're going to do is find the difference of the two values. The difference of the two values is equal to 15,202.44. The last step we're going to do is finding the square root of this value. The square root of this value is 123.298 inches. Don't forget the unit. That is how to solve the problem for our right triangle.
That's more than 1 minute! See you tomorrow!